So in carbon storage, basalts are really interesting because typically if you put the CO2 into the ground, the reactions are much slower and take decades or hundreds of years to get to a large amount of mineralization. But you're talking about days, weeks, and months for basalts. So thank you very much for that. And we'll move on now to Matt, who has experience in the commercial area in capture, transport, and storage.
After you introduced me the way you introduced me earlier, I was very glad, number one, that everybody's sticking to 2 or 3 syllable words for me. It's helping. And the other part that it reminded me of is I went to KU and got an environmental engineering master's degree, and I paid for it at night. So I worked nights at Lawrence High School full time, and I was taking a class called Industrial Wastewater Fluid Dynamics and Corrosion Control from Dr. Burkhead. And at night, I would go to the school, go into the tunnels, and strip out all the water pipes. So it had all corroded out. So I was cutting it out, cutting new pipe, threading it in, running it in. And after about a semester, at the end of the semester, I went up to Dr. Burkhead and said, I just want you to know how cool it is that I'm taking this class that's talking about the anodic and cathodic principles of dissimilar metals and how you're going to have this increased failure rate. And at night, I'm seeing it in reality. And he said, really? I've been teaching it 35 years and I never knew if it was true. And I just went, oh my gosh, okay. So kind of along the lines of what we've been talking about and how exciting this is as a disruptive technology right now, something Bob had told me actually 4 years ago, and I agree. Secretary Kennardine was talking about gas and tight gas and shale. And I've met someone who wrote a dissertation on a plane who told me he wrote a paper that said it was absolutely impossible to get gas out of shale. And of course, he was wrong. So a lot of people have been successful. Along the same lines on carbon capture and pipelines, it shocks people to know that it's being done, and it's been done for many years already. We have CO2 pipelines, especially in New Mexico. CO2 pipelines with pure CO2 coming from the north to the south. We have the CO2 and water I told you about yesterday. H2S coming out of the ground in all the wells, and gas processing, as Secretary Kennardine talked about earlier today, that's their job. It's what they do. They strip out all these impurities for a fee. So the Exxons, the Chevrons, and all the other guys will drill the well, produce the well, and then they'll send their gas to us to get the water out, CO2, H2S, other impurities, the condensates, the NGLs. And we charge a fee for the service. It's a specialized service, and strip that out. And we send the gas down to the Kinder Morgans and the places that send it up here, send it to California or to the Gulf Coast for power plants, for home heating and that type of thing. And again, that's been going on for years. One of the coolest things from a historical standpoint that I finally figured out, I'm working with a gentleman named Paul Ragsdale. He was the Yates operation manager for many years. And around 2004, 2003, the Dagger Draw gas plant in Artesia was hit with compliance, what do you call that? Consent decree from the NMED. Excess emissions from processing gas with too much H2S in it. And he did a bunch of asking around, and it gets to the point Matthew brought up yesterday. If you lays the target and say, this is the target, there are so many people in the field and in academia, like we're talking about here, which I love, that understand what to do to resolve it. You just need to have groups like this get together. So he ended up finding someone from Encana, and in Calgary area, they had resolved this problem with H2S and had created this acid gas injection well I was telling you about. So this SWD that was serving the gas plant was converted with support from OCD, UIC division, and the commissioner at the time, who was a guy named Dr. Balch, to support the change from an SWD to an AGI. All that H2S went out of the air, all of it went into the subsurface with the CO2, and the plant was back into compliance. NMED's happy and all of that. So just going along, and what we have right now, again, starting with Dagger Draw gas plant in 2005, there's around 24, 26 AGI wells right now in New Mexico. And as discussed, you guys are dead on. And again, I pointed this out yesterday. A lot of states don't have what New Mexico has. They don't have the place to inject and sequester. They wish they did. They don't have the natural gas. They wish they did. So New Mexico is just sitting on this rich environment for what we're talking about right here. 24 wells, and also this is in the Permian and Midland area. Like I said yesterday, we're drilling a well right now. We're seeing the fluid dynamics on that well. We're through the Delaware Mountain Group this morning. It's really exciting to know that there's so many people that are very good at this and know how to drill the wells carefully, safely, and put the CO2 away forever. I pointed out earlier yesterday, and I think it's very important, we're injecting H2S as the 10% component of this 90% CO2, 10% H2S. 100 parts per million of H2S will kill you instantly. We're injecting 300,000 parts per million of H2S into the ground to keep it out of the atmosphere. And if there was an issue with the caprock not holding or any of these things since 2005, we would know it from the H2S standpoint for sure. That's so much more dangerous than what we're breathing out right now. So that said, what's been really neat to see is how the class 2 wells and evolving into the class 6 wells and the awareness that all the states are getting right now is the elevated expectations for class 6. So again, we have pipelines. We're moving it every day. There's a 7 o'clock call every morning where we have 35 compressor stations moving this stuff around the Permian. And I actually have to correct something that I may have misstated yesterday to Bob. The 99.98% is methane capture. So we're capturing 2 billion cubic foot of gas a day that leaves, and we're losing 0.02% of that when people talk about methane loss. So it's just kind of outstanding how that the guys do keep this going, but we can always improve. So beyond that, what we're talking about now and all of the wells and what we've been doing with support from the PRRC and the CUSP is upgrading the way we've done class 2 wells. First off being the 3D seismic. First time I met Bob, he said, you really ought to get it. And I said, it's expensive. We don't need it. And I was proven wrong. I had to like eat crow, and we did 3D seismic from there. All of our wells have a DTS cable, so distributed temperature sensing cable on the tubing. And that has already proven to be invaluable because that fiber optic can sense a leak right at that location in the tubing. This well we're drilling now is 19,000 foot. It's kind of hard to find a leak when you're just doing an MIT, checking for a pressure differential on the annulus. But that fiber optic tells you it's right here. Here's where you need to work on it. And it gives you a preliminary warning instead of something that's at failure mode with an MIT. The other thing we're doing with fiber optics is DAS. So distributed acoustic sensing cables on the outside of the casing allows us to do a baseline of what the formation looks like before we inject and be able to identify where the plume is going to be. And again, that comes from class 6. So these are some things we'll talk about later on monitoring, but the technology that's out there is just been great. And one of the changes that we've actually implemented that is just something that was a brain snap, really. All of our pipeline, we have an entire department that does corrosion control. They place the corrosion coupons in line. They have the anodic, cathodic principles. They minimize corrosion and everything buried in the ground, check for any line breaks, any shorts, anything that could be a problem. So we know that pipeline's got integrity. Class 2, we never did that. In fact, no one does that. But now we're all talking about, all right, we're going to do this. We're going to put a corrosion coupon in line before injection. So we're going to be able to pull those coupons, measure the expected loss of the wall while we're injecting. And it's such a simple thing, but it's just, again, something we hadn't thought of, and a lot of people haven't. So in these discussions we're having, it's going to be great to see industry step change by taking the data that's being presented here, because I cannot say enough good things about the CUSP, PRRC, and the education that we've all given ourselves and the cross education. But we will see these changes. And frankly, we have to prove that. If we want to do carbon capture, we have to prove to the public that these are the things we do to be protective, because it can be dangerous if you're not doing it right. You can damage the water table forever. You can cause seismicity. So the technology has been introduced here. You know, we are doing it now, and it's been really exciting to do it. And with that, I'll yield the floor.
Great, Matt. So you may have noticed we're already 5 minutes past our time, but John Lucien has graciously donated us 15 minutes of your coffee break to make up for the wonderful amount of knowledge we got from Melanie this morning. So I'm going to rapid fire one question at each of these gentlemen and then leave the last 5 minutes or so for questions from the audience. So starting with Raj. One thing that really gets in the way of capture, especially direct air capture, is cost. So what is kind of the current price to capture CO2 and what are the target prices?
So yes, so cost is a big factor because you're pulling CO2 from a stream which only has 400 ppm compared to like a point source is could be 9 or 13%. So there's a huge difference there. So you're moving so much air through a sorbent bed or something. The capture media, it takes a lot of energy and then it has to be regenerated. So cost we are looking at depends on the technology, but you can easily see maybe $1,000 to $2,000 a ton right now. And that also depends because those are deployed at pretty small scales. And then as we scale up, we'll get the economies of scale and the cost would go down. The one factor which help us reduce the cost of DAC is using the excess energy available as well as the waste heat available. So for example, in Iceland, they're using the geothermal energy, which reduces the cost drastically for the DAC. So other factor comes in is the material cost. If the lifetime of material is improved, that would reduce the cost. So there's quite a few advancements have to happen to reduce this cost, but currently it is very expensive to do direct air capture.
Bayan, 65,000 miles of pipeline. There's going to be some technical and regulatory hurdles to accomplish it. Would you address those?
Well, I think technically, the sealed transportation is very mature, right? So I don't think there are much those kind of technical challenges. I think the challenge is mainly from the permitting and the regulatory side, especially if the pipeline goes through let's say the travel lanes, right? So I think probably much more difficult to get those kind of permits. It's, for example, get access to the land and also get the permit to construct pipelines. So I think, I think what we need to do is more kind of collaboration between the government and the public in terms of how to streamline those kind of permitting process, right? So that we can reduce those kind of uncertainties in the CCS projects, right? And also, I think we need more kind of knowledge sharing to community. So especially, I think a couple of years ago, there's some CO2 pipeline leakage happens, rupture, right, in Mississippi. So so I think the public need more information about what will be the impact if those kind of release event happen. So actually, Los Alamos team are working very hard in terms of developing different models to kind of predict what will be the impact area if there's any kind of leak events happened. So we need those kind of modeling tools as well, to help public to understand the risk.
So it comes down to communities, I guess.
Yeah.
Okay. Sai, you talked about an exciting new area for storage, but what happens right now is it mostly goes into saline aquifers or depleted oil fields, right?
Yep.
So what happens to CO2 kind of chemically when it goes into the ground and how secure is that storage? How much of that CO2 could come back out later, potentially in a leak?
Wow, this is a tough question,
He worked for me, so he gets a tough.
So let me say it like this way, at the very early stage, when we pump the CO2 with water to the basaltic formations, those kind of CO2 gonna enter to the pore space at the early stage, probably 30 or 40% of them. And with the time passing, so those kind of CO2 with water gonna react with the mafic, ultramafic rocks and generate the carbonates minerals, okay? The potential for the leakage gonna be minimized from there because we generate another type of the rocks, okay? It's not like the traditional deep saline aquifer storage. We heavily depend on the caprock. So through these kind of chemical reactions, we kind of like generate another layer of the caprock in this formation. And also there's a potential for the reaction rate between the dissolution and precipitation. Which one is faster? Okay, what's the mechanism behind? And then if the precipitation reacts faster, then is it gonna help us to open more pore space or fractures for us to pass a lot of even more CO2 into these formations. So that's a pros and cons right there. So how to control this kind of reacts and how to minimize the leakage risk is the topic we are working on right now. And hopefully it's gonna be a positive outcomes. Yeah.
Great.
Thank you.
Thank you. So Matt, from the industry side, could you talk a little bit around the impact of tax credits like 45Q that incentivize people to put CO2 in the ground by paying them tax credits?
Yeah, I ran some numbers earlier because you gave me a little bit of a heads up, which I appreciate. So just for our Red Hills field treater, the overall cost for that was $130 million to install. It's currently processing 7 million cubic foot per day of TAG. Again, TAG is that percentage of H2S CO2. Break that down into the 80-20, and it's about 5.6 million cubic foot per day. You get down into, you have that $130 million plant to around 107,000 million tons of CO2. Your cost is about 1,215 per ton CO2. That $85 a ton helps us pay it back in 14.3 years. Now, that said, that's if you were to go out and start from scratch that I'm just going to inject CO2. Obviously, we build these plants for other reasons. So we're building the plants to charge the fee to the client to clean it and strip out the H2S and CO2. So there's a benefit for the fact that it's something Bob had pointed out to me earlier on with that first DOE grant. It's a shovel-ready project. It's happening now. So there's these incremental increases or additional dollars we could spend. And that's where that comes in. So talked about it yesterday. The field treatment, the CO2 stripping it into the field, there's no value whatsoever in adding bigger compressors, larger energy costs, larger pipeline to send that to inject it. But with the $85, it incentivizes you to say, okay, we are going to increase all the capacity to bring it to that well and inject. And so it does incentivize. And I do believe that, 10 years from now, it'll just be the way we do things. I think the world does things. And I do think the DOE seed money works well in that area. But right now, it helps push it past the financial reviews as far as, why are we doing this if we're just going to lose money on it? So it brings that money in.
Thank you very much. So we have a couple minutes for questions. If anybody has something that they would like to ask the panel.
I'm an engineer, so I just have a simple question. What kind of pipeline materials do you use to transport CO2?
So, can you hear me? Yeah, so that's a really good question. Different type of kind of pipelines, the materials. So I'm not actually expert in that area. I think the X51, X75, right, those kind of pipeline, materials usually used in the CO2 transportation. So maybe, yeah.
Yeah, and I'm not the best one either because most of ours is gas and water coming through. So just pure CO2, I'd be reaching if I were to tell you. And I'm also more on the regulatory side.
Pure CO2, you can move in regular mild steel. If there's any water vapor or anything in there, then you have a chance for corrosion. So a lot of the big CO2 pipelines, those are stainless steel, some mix.
Yeah, well, I have a question. I'm here.
And George,
So Bob, a question for you, and I don't know the
I'm
answer to
I'm
this.
not on the panel, I'm just the moderator.
Uh-huh. Uh, uh, how many actually projects around the world, not, well, let's say the United States, how many projects injecting CO2 on volumes that's actually viable to bring us to where we want to be? I know the AGI wells, these are actually the ones injecting. I know the ADM project, but did we even get to a place where we have actually projects now actually injecting actively with the volumes we project to inject?
Yeah, so Jennifer showed me a slide. There's about 90 projects worldwide and 39 of them are in the United States.
Volume,
That would be a good question for Jennifer.
volume?
Not enough is probably the right answer.
Exactly, that's my point again.
It's a good start.
Thank you.
Bob, can I add a little bit on?
Yeah.
So, I was in North Dakota for a while. I drilled the first two Class 6 well of them. So back to 2019, they have the RT10 well for the Class 6 well, and they get a permit back to 2022. So 2023, they already started the injection in the large volume. So another well is the I forgot the name, but they got the permit early this year. They are already starting the injection right there, which is large volume. Okay. Last month, oh no, early this month, North Dakota got the compensated phase 4 project right there. So they have another well right there starting the injection. And also Wyoming, I think they are trying to promote their injection well as soon as possible since they have the primacy. From industry, I believe Louisiana, they have the injection activity already. So New Mexico, I really hope we can make this happen very soon. Thank you, Jennifer, for leading this primacy effort. And if we got the primacy for the state, this process for the permitting gonna be much quicker than goes to the EPA Region 6 or EPA Region 9, whatever. Those gonna help us a lot. Yeah, thank you.
I do want to make something very, very clear. If New Mexico regulates Class 6 wells, they have to demonstrate to EPA that their standard is as tough or tougher than their standard. So it's not like we've taken any shortcuts. We're just administering it more efficiently. So I think we'll close there. Only 10 minutes left for coffee, but thank you very much for listening to the panel.